come closer and have a look in the cross-section of the tires, and you will see that there are multiple materials inside. So when you undergo a first mechanical recycling process, you will receive 3 material streams. That's the steel from the wires, the rubber, and textile fibers. Let's start with the textile fibers. So when you put the textile fibers on a flat surface and you undergo through a needle punch process, you will receive a dry laid non-woven material, which looks like that. With only 10% B-component fibers inside, we can fix these non-wovens in specific geometrics and use them, for example, in absorber mats for acoustic reasons in the near of the tires. You can see an example on the screen on the right side where we put it on the area of the wheel. So a little bit more complex is what we can do with the rubber. So you really have to break down the rubber to the monomer in a chemical recycling process, which means that you, in the end, you will receive kind of an oil. And with this oil, you will be able to make new polymers, so new plastic parts. We already use that process in serious production, and for example, this is the door handle from the current S-Class in the market, which is done through this process. But we are not only able to make black parts and stiff parts, we're also able and in a position to make the material soft and white. So we can do that through this sheet. And from one tire, we're able to make 4 square meters of these sheets. And this sheet contains 60% from the old tire. So this undergoes a treatment through bio-based proteins, which are pretty similar to the proteins in your skin or the proteins from the skin in a cow. So it's actually a little bit the same like leather now, like the cow skin. So the tanneries can proceed with this in exactly the same way like they would do with the cow skin, because you have around every fiber these proteins, the mechanical interaction in the material is kind of the same that we have with the normal leather. So the materials doesn't even look, it also feels and smells like the real leather. Through this process, and because of the fact that we can design the material down to every fibers, we have superior mechanical performance and also thermal stability in the material itself. It's a great example to not only make a material more sustainable, also luxurious and high quality. For the steel topic, I hand over to my colleague, not only for the tires, but in general.
Christoph, thank you very much. I'm responsible in the car body development for metals, for forming and other topics. And some years ago, my boss is coming to me and said, okay, you have the most metal in the car. You have to look also at sustainability topics. And some years ago that starts, and we accelerate in this field because with the steel or the aluminum, you cannot see a difference between primary, you cannot see it, between primary aluminum or steel or secondary material. So we start with aluminum because aluminum has a very high energy demand, very high. So if you use secondary material, and this is processed material like this, you only need 5% of the energy to melt this. So, but for outer skin like this, a cyborg, you have special requirements. You have to paint it. We need also the class R surface, corrosion is a topic. And if you do not process, I always say we have bad post-consumer scrap